last thing we're going to look at is powers of complex numbers. The trigonometric form of a complex number is used to raise a complex number to a power. To accomplish this, consider the repeated use of the multiplication rule. So z equals r cosine theta plus I sine theta. So if I did z squared is r cosine theta plus I sine theta times r cosine theta plus I sine theta. Notice we would get r squared cosine of 2 theta plus I sine of 2 theta, right? You're just adding those thetas together and you have two of them. If we get z cubed, that's r squared cosine of 2 theta plus I sine of 2 theta, multiplied again to the r cosine theta plus I sine theta. Notice what you get is r cubed cosine of 3 theta plus I sine of 3 theta. And so you're probably noticing the pattern there. So z to the fourth is r to the fourth cosine of 4 theta plus I sine 4 theta, and so on. So that leads us to DeMoivre's theorem. Let z equal cosine theta plus I sine theta as a complex number and n is a positive integer. Then z to the n equals r cosine theta plus I sine of theta raised to the n. And let's do this actually. And then what happens is you plug it in and you see that it's r to the n, right? You distribute it through r to the n. And then it's cosine of n theta plus I sine of n theta. So example 7, finding a power of a complex number. Use DeMoivre's theorem to find negative 2 plus square root of 3i, all raised to the 12th power. So we know that this is in this quadrant, left 1, up root 3, so it's in quadrant 2. So let's find r first of all. So r, remember, is just a squared plus b squared, and then you take the square root. So the square root of 1 plus 3, or square root of 4, which is 2. R is 2. Then we have z equals negative 1 plus square root of 3i. So let's rewrite that in our trig form. So now this is 2 times cosine of, let's see, so we need to find this angle here. So let's think about theta. Tangent of theta is b over a. So that's square root of 3 over negative 1. So when does that equal that in this quadrant? And that is 2 pi over 3. So therefore, this is cosine of 2 pi over 3 plus I sine of 2 pi over 3. And then remember, we're trying to find it to the 12th power. Well, this is the first power, first of all. So if we do to the 12th power, let me just rewrite that. Here, that's to the 12th, so we have to do it to this side as well. So it's 2 times cosine of 2 pi over 3 plus I sine of 2 pi over 3, all raised to the 12th power. So according to the formula here, we're just going to distribute this n in, right? So you put it here to the power of, for the radius, so r to the n, and then multiply it to your thetas. So this is going to become 2 to the 12th power times cosine, we're multiplying 12 times 2 pi over 3 plus I sine of 12 times 2 pi over 3. And then 2 to the 12th, that ends up being 4,096. And then 3 goes into 12 4 times, so this ends up being 8 pi plus I sine of 8 pi. 8 pi we can really think about as 2 pi. So therefore, I forgot my cosines here. Cosine of 8 pi. So cosine of, what is cosine of 8 pi? Cosine of 8 pi is 1 plus I sine of 8 pi is 0. So therefore, the final answer for this is 4,096. So try this example here. Use DeMoivre's theorem to find negative 1 minus I, all raised to the 4th power. Now you're still trying to find r, still trying to find theta. It looks a little different, but it's still the same. All right, you would find that the radius is square root of 2. Theta is 5 pi over 4. It's in quadrant 3. And then when you plug it all in, you would get negative 4.